Hello. Right at outset, I want to make a humble request to you. I am 56 years old, working as a principal in a school, and man of limited resources, a man of limited knowledge. I had no wish to become famous or something. I was very happy with the way life was going on for me till now. But in the times of corona crisis, when the things have come to grinding halt, my heart aches for all the people who I feel are incarcerated, locked inside their houses. So, through these videos, my only intention is to reach to the last child whom I can help. So, with the knowledge that I have, I promise to you that for the class 9th and 10th, complete science and mathematics. For every topic I will put videos, and if you find them the worth, please do help me to help the people. Not a single NP I am going to get benefited from these videos. Only thing is that I want to reach the last child. Now coming on to the subject, in continuation with the chapter of our magnetic effects of electric current. Now this is further to what we were studying, that how to say, I said magnetic effect of electrical current. So if we make electricity to pass through, this conductor will become magnet, developing a magnetic field around itself, and that will have some influence onto the compass. This is a compass, compass is a small magnet, this is a magnet, this is magnet, and they will have interact with each other. So this current will make it magnet, that will cause a deflection into it, which will prove it that when current is made to pass through a conductor, that becomes magnet or develops a magnetic field around itself. Oersted was the man who did this experiment, and he was the man who proved this, that if current is flowing through a conductor, that becomes magnet. Also Oersted gave us a law which was known as Snow, law of Snow, S-N-O-W, Snow. To explain this, I will come to here. These are the directions written as geographical north, geographical south, geographical east, and geographical west, so that we don't confuse with this north and south. This is the north pole of the magnet. I told you this is a small compass, and compass is a magnet, and this is the south pole of the magnet. Now if current is passing through this is the positive terminal of the battery. Current is passing through this, from south to north it is moving. And the another condition is that this wire must be over the compass. Says here is the compass, then wire must be over. Compass is like this, wire must be over that, and current through this must flow from south to north. So in this figure, if you see, geographical south to geographical north current is flowing, and this wire is kept over the compass. And then in that case, the deflection of the compass will be towards the geographical west. That is, in the west direction deflection will come. If it happens the other way around, that is, current is flowing from this terminal and it goes like this, then the current is flowing from north to south. North to south, then the deflection of the compass, needle of the compass, will be towards the geographical east. This was the law given by Oersted, and he said snow. Snow means south, N stands for north, O is over the, that is the conductor must be kept over the compass. That is, compass should be underneath. Compass should be underneath, the wire should be over, and then if current goes in this fashion, it will move to the west, and if current comes from north to south, that will move to the east. This was all about Snow law and Oersted experiment, and this was enough to prove that how magnetic effect of current could be experimented, felt. Now further I will tell you what is the magnetic field, pattern of the magnetic field, and the strength of the magnetic field, that depends upon what. So I will make it this way, like this time. This is a battery, let us say, and this is positive, this is negative. Current is flowing like this. This is a compass, and this time we will simply ignore the direction. This is north and south in normal times, when let us say the switch is open, current is not flowing. The switch is open, current is not flowing. This will align to north and south. When we close this, the deflection will be caused into the current will start flowing through this. This will become a magnet, and if it becomes a magnet, developing a magnetic field around itself, that is going to have some deflection in this. Now to see deflection is because of the magnetic field. So there will be 2 points that we will study here. One is the strength of magnetic field will depend upon what? That will directly depend on the strength of current. Strength of current. If you make 5 ampere of current to flow and the deflection is less than when you make 10 ampere of current to flow. So strength of magnetic field will decide the amount of deflection through which this needle will move. The amount of deflection will be decided by the strength of magnetic field, which in turn will be decided by the strength of current. So we can say here the strength of magnetic field, which is developed around a straight current carrying conductor, directly depends on the strength of current. Strength of current. Second thing is, if you keep in the close vicinity, this compass is kept in the close vicinity of the wire, that is kept closer to it, the deflection will be more. If you move it farther apart, the amount of deflection will be less. So you can say the strength of magnetic field inversely depends on distance from wire. And third point that we can note down here is that by changing the direction of current flow, direction of deflection can be changed. Now if I am telling you, let us assume current is flowing like this, and then say it is deflecting in this direction. Then when the current is reversed, the direction of deflection also will get reversed. This was about how to detect the magnetic effect of current. Then the strength of magnetic field was depending upon one. Strength of magnetic field directly depend on the strength of current. Another, it was distance from wire, and on that it was depending inversely, and direction of deflection of this needle could be changed by changing the direction of current flow through this. Now further we will study what is the pattern of the magnetic field that is developed around a straight current carrying conductor. So this is our straight current carrying conductor, let me say, this is switch, this is positive terminal, this is negative terminal, and like it we said, we have connected like this. When the switch is put on, the current will start flowing, this will become a magnet, and this will cause a deflection. This is north and south normally, this will cause a deflection. So the deflection we have already studied. Now we will study what is the field pattern of the magnetic field. So around a straight current carrying conductor, the pattern of the magnetic field is concentric circles with their center line on the wire. The magnetic field that will produce around a straight current carrying conductor will be in the form of concentric circles with their center line on the wire. Now next thing that we will try to find out is how to find out the direction of the magnetic field in this case. See, most of the books just say one thing, and that is they say Maxwell's right hand thumb rule. Let me write here, it is Maxwell's right hand thumb rule. So what does this rule state? This rule states that imagine you are holding a current carrying conductor into your right hand in such a way that your thumb points the direction of current flow. This is a small one. I am holding it like this. The current is flowing from bottom to top, and my thumb points in the direction of current flow. Then my fingers encircling the conductor will give you the direction of magnetic field. Maxwell's right hand thumb rule. Maxwell's right hand thumb rule is used to find out the direction of magnetic field that is produced around a straight current carrying conductor, which is of the pattern of concentric circles with their center lying on the wire. Now to say this statement, that imagine you are holding a straight current carrying conductor into your right hand in such a way that your thumb points the direction of current flow. Then your fingers encircling the conductor will give you the direction of field. This is half the information, and in 90% of the books only this is said. See gentlemen, this is a circle. Your fingers are making a circle, and circle has got no direction. So I have further added few information to this, and I say it so that imagine you are holding a straight current carrying conductor into your right hand in such a way that your thumb points the direction of current flow, and then your fingers encircling the conductor will give you the direction of magnetic field in such a way that the head of the arrow indicating the direction of magnetic field will lie at the tip of your finger. Here see, tip. Head of the arrow indicating the direction of the magnetic field will lie at the tip of your finger, and its tail will lie at the root of your finger. So in this direction, if I say the current is flowing, so this becomes like this. So thumb in the direction of current flow, fingers encircling like this. So if this is the arrow, this is the arrow indicating the direction of magnetic field, then the head of the arrow will lie at the tip. You can see it here. This is the tip, head will lie at the tip, and tail will lie at the root of finger. Now the complete information is given. So to state this, Maxwell's right hand thumb rule is used for finding out the direction of the magnetic field that is produced around a straight current carrying conductor. And how does it found, or how does it indicate? So that we will say. Once again, let me tell, though it is, I am repeating it so many times, but no problem to make this law very clear. Once again, let me say that imagine you are holding a straight current carrying conductor into your right hand in such a way that your thumb points the direction of current flow. Then your fingers encircling the conductor will give you the direction of magnetic field in such a way that the head of the arrow indicating the direction of magnetic field will lie at the tip. Head of the arrow will lie at the tip of your finger, and its tail will lie at the root of your finger. So this was all about Oersted law. Then the straight current carrying conductor, we found the magnetic field strength depends upon what? The strength of magnetic field depends upon what? Also we found what is the pattern of the magnetic field. Also we found what is the direction of the magnetic field that is produced around a straight current carrying conductor. Thank you.